Hello, hello, hello. Please thumbs up if you hear us and if you see us. Hello, Eric.
Hello, Alex.
Yes.
Running a little bit late today, but that's okay. We're having some technical issues, but bear with us. We're finally live now. So give us a thumbs up if we're coming through okay.
So, sound ok and video hopefully is ok too. So we can start, and that's great. Yes, we are all good and we can start. So first of all, welcome to a week 4 episode of the Cassandra Cloud Native Workshop series. Here is with you Erick RAMIREZ and Aleksandr VOLOCHNEV, developer advocates at DataStax. And sorry for a little delay, those are little technical issues, but finally we are together with you so we can start.
Thanks everyone for joining us again this week.
Yeah, it's a big pleasure. Okay, so it's a week 4 and you did already a long way. You did some of the Cassandra fundamentals, data modeling. Hopefully, if you didn't, you should. And then last week, first development with Apache Cassandra, and that's week 4. And we speak about APIs, microservices, and in the end, we have a special surprise for you, surprise you will like. So, let's go on. I cannot start without speaking a couple of words about the team who works here with me together, all of us doing those workshops. Those are great people, and they are here with you now in Discord and in the YouTube chat, answering your questions. And as said, that's not only Cassandra, that's in general to make you ready to work with microservices in a modern cloud native environment, all in the clouds. So next week, we're going to be more about Kubernetes and running your applications in the clouds, and also testing, because you don't want to deliver an unready application what's lagging all the time. No one loves that. So we're taking testing very seriously. Now, let's do some preparational job. We're going to do a lot of things today, Cassandra in microservices, APIs, endpoints, how to access that, REST and GraphQL and gRPC, a little bit of Quarkus, and a little bit surprise in the end. Let's start with the housekeeping. We expect you, and as it's a week 4, we do expect you, for real, to have some, first, understanding basics of a Cassandra. Second, already created an Astra instance. If you didn't, you will need it for the exercise of this week. You will need to have knowledge with Cassandra data modeling, so week 2, sorry, and to know basics of one of the following languages. Notice the word basics. We aren't requiring you to be a true guru, a rock star, or with whatever Java. But exercises of this week expect you to use Python or Java or C#, and you don't have to install anything because everything is ready for you in the cloud as like very cloud native. If you
And just while we're on the subject, Alex, so I just wanted to point out, so we've got the link on the bottom of the screen at the moment, bit.ly/Cassandra Workshop Materials. I know that a lot of you are asking lots of questions. In the week 4 materials and homework page this week, there's a lot of FAQs on that page. So it's just that URL just in the bottom of the screen. Go to that page, do us a favor and do yourself a favor. Have a look at the FAQs, the frequently asked questions on that page, and before you ask a question, because we probably already answered it. And just so we can go through this really well in a smooth fashion.
Absolutely. And well, and finally, if you don't have experience with any of those questions, we recommend to choose Python as the easiest one to run and start and do the things. But again, don't worry, we do not require any serious knowledge like big knowledge. Then There are some links you need to know during the exercises and streams of this workshop series. First, we do live streams at YouTube. Mostly probably you are watching this video at YouTube right now as a live stream or as a recording, same link. And we have a plan B. If something goes wrong with YouTube, we're also streaming the same time at Twitch. So if you're a Twitch fan, maybe you would prefer Twitch. But we do not support Twitch. I mean, we don't write answers in the comments. So if you are on Twitch, you are on your own. Or you can use Discord. For live questions, we recommend to use Discord. And also you can ask questions at YouTube chat. But well, Discord stays available always, and YouTube chat is available only during the streams, live streams. Materials and help, well, that's first of all DataStax community, and this gentleman to the left of me, or for you to the right, I believe, a master of our DataStax community and answering questions. And Bettina Swinnerton is also doing, they are doing a great job there, answering questions and helping you getting a better developer skills. Then astrodatastax.com, that's our database. Cassandra as a service, you should be familiar with already. Then GitHub, our main thing, we are storing all the materials here, GitHub. DataStax Academy, Cassandra Workshop series. I believe you know this already. And finally, Gitpod. Gitpod is a great tool making you running Git repositories directly in the cloud and having all your IDE integrated development environment features available for you. And before we start, I need to ask a few questions. And we go to menti.com. Code for today, 436982. I repeat, 436982, and we are going to ask you some questions. And thank you so much for answering our questions.
So go to Menti on your phone. Don't follow the stream. Don't look at the questions on the screen because it's going to be delayed by 2 seconds or something. So do it on your phone.
Yes. Good. So Menti, I see more and more people are here. Then thank you so much. Every of your answers is very important to us because it really helps us to understand what's the audience, in which fields you are the mostly skilled, so we can adapt our workshop series to be mostly fit for your needs. So very much thank you to everyone who is answering. And I see already really many dozens of people has joined the Menti. So again, menti.com, code 436982. While we are waiting, Eric, you are master of our questions and answers, and we're receiving a lot of questions during the workshop series. What would you call like the best question of the last weeks regarding to the workshop series? What do you like it the most?
Oh, we do get lots and lots of questions. I think one of the biggest questions that we had from week 3 was a problem when people were having issues getting connected to the Astro database using the app code, and so we've got that in the FAQ as well. That's available if you go and have a look. It's usually because people got the path to the secure bundle incorrectly.
Yeah.
That was a hot topic.
Okay, so we have a lot of people and we can start now. That's not a quiz, so no hurry. Think of what you're answering, okay? Don't be in a rush. Let's go on. 3 questions to adapt the content and our talking points. Thank you. Where are you in the workshop series? Still working on week 1 or 2? Week 2 completed, working on week 3. Week 1 and 2 and 3 completed. I've only watched workshops. I saw this live on YouTube and clicked. So how deep are you into the workshop series already? If you are not so deep, if you are at week 2 or 3, again, no worries. You can watch the recordings, ask questions at Discord and or the community, and move on, do your exercises at your pace. It's like self-paced course, we can say, but what's important, do your job, do your watch your recordings, do your exercises. It really helps you to become efficient cloud native developer. Good. So I see most of our attendees today are or working or week 2, 3 or week 2, 3 completed. If you are still working, again, don't worry. Take your time. We are here for you. And if you are only watching workshops, it's still very useful. So next question. Are you using microservices in production? Yes, for all departments. We have started ongoing. I wish I could, but I haven't not yet developed applications. Take a look. It looks like we have a lot of students here today.
We do, and we do have a lot of other helpers too. So apart from the usual developer advocates crew, I just wanted to acknowledge that we've also got Jeremy, Hannah, and Yoshi helping us today. Yoshi Kimoto from Japan.
Yeah, Tokyo. That's really great. That's really incredible. So we have so skilled, so experienced people directly at the live stream answering questions. If we count experience of all of them, of all of us, let's say, I am absolutely sure it will exceed 100 years or maybe even 200. Okay, so we see. Oh yeah, I wish I could, but legacy 20% green chart. I am with you. I do understand how it feels. That's fine. And those who started, congratulations, because well, this kind of reworking is very important. And yes, for all developments, congratulations, you were the fastest. If you haven't yet developed applications, don't worry, we will explain what's going on. And then
yeah, exactly. You're in the right place.
Yes, yes.
If you haven't developed applications yet for microservices.
Good. Now question. Do you deploy applications in the cloud?
Yes, I can see it, Tech Junior, on YouTube chat. You get a shout out.
Okay, wait a second, Eric. I have to fix your poster, your picture here. Just a second. Great, so you are back with us. Okay, so I see I haven't yet deployed applications, it's fine. Then no, that's also fine, part of them, all of them. So as you take a look, almost half of people at least have experience with the cloud, fully or partially, but also a lot of people are staying to the self-hosted solutions or things like that. And that's very understandable. Well, clouds are getting stronger and stronger, but not yet fully adopted by the companies, especially when we work on the huge monolithic code. Well, that's pretty typical. Again, if I have not deployed applications, well, first of all, that's mostly about developers workshop, and therefore that's not exactly your job to deploy the applications. So that's also fine. Thank you so much for answering our questions. And let us proceed with the talks. So let's start then. Cassandra and microservices. Very many years ago, like dozens of years ago, the one and only way to develop applications was pretty monolithic. It means what your front end, your model part, your database part was all together like in a single big application. And it brings some benefits in the beginning, especially. But following the development of the application, it becomes too big, too messy. All components, all parts are communicating with every of them. It's what's called tight coupling. So tightly coupled code is the code which is so much connected every part with each other. So when you want to refactor it, it's nearly impossible because it's all just too connected to each other too much. Every line of code, changing one line of code may change behavior of your application in completely different part of this application. You would never know. Even good testing sometimes can't help. And that's what called a tight coupling. Then your code is too much connected source code. And people wanted to get rid of that. People wanted to have their applications maintainable. People wanted to decrease those coupling, make it more loose, soften that. And first step at this way was done with multi-tiers application that's also known as open architecture applications. When there were a split, separately front-end application, like nowadays that's typically JavaScript. We are talking about the web therefore, and separate backend, and data later is also isolated. Those parts communicated with each other using API. So for example, when you call any database, or like Cassandra, you're using SQL, for example, or SQL, with some drivers for relational databases. And for example, your front end communicates with your backend using JavaScript, and therefore all those Ajax calls, reactions, and communicates using Ajax, for example, and all the asynchronous calls. That makes parts, so that split application apart, and it was for good, because now your code was decoupled, or at least less coupled, and that makes you able to bring the changes, or I don't know, scale some parts easier than with complete monolith. Next development of this idea of the decoupling, of the isolation of the components, was SOA, service-oriented architecture. And idea was very simple. Your backend part, usually the biggest part, is being split into multiple services running standalone and communicating via ESB, Enterprise Service Bus. So Enterprise Service Bus was responsible for communications and connections between services. And it was a big step forward. I did a lot of applications in this style, and that was a big step forward. That brings so many benefits for the projects, especially for big projects. There are not 1, 2, 3, 5 people are working on a project, but some dozens or maybe hundreds or even more. So every company, every team was able to work at a single service and have its own architectural technical decisions. As long as service can communicate with Enterprise Service Bus, it's perfectly fine. So now you don't have all your code together running in a single app and a single instance, but you have parts of your code running isolatedly from each other. Code is much less coupled, and that's another some benefits, like if you have highest pressure at one of the services, at one of the parts of your application, beforehand, you should have been scaling out or up the whole backend as a single piece, because it's just single brick. You cannot split it apart. And with service-oriented architecture, you can scale up exactly the service which is the mostly loaded at this moment, having therefore much less duplication. And it was a very good approach and very big step. Good. And you know what? We are in 21st century, and there are some things keep still changing. Coming of the microservices architecture was also a very big step in the same direction. The idea is basically the same, but now the approach to communicate, for services to communicate with each other, was different. So the idea was to try to remove single points of failures, like enterprise service bus. Because if your ESB is down, whatever services are running, they cannot communicate. So we're thinking of the idea of graceful degradation. If one of your services, non-essential service, is down, all the rest of the parts of application must be working. And with things like single point of failure, SPOF, you may have troubles. And to reduce that, we are making services able to communicate with each other, and to enable them to find each other, we have service discovery, like service auto discovery, things like console, maybe you know, like console from HashiCorp and things like that. So services communicating via API gateways, able to find each other and communicate. And another idea was also to isolate front-end related things. So now we have single page applications, web components, and they may communicate their special backend for front-end approach, which is kind of an API gateway, we can say, for them front-end applications to make them able to communicate with backend applications. And if you are doing microservices already, I'm absolutely sure you run into the trouble like I've seen so many times in my developer's life. People start do microservices without real understanding if they need that or what or not, if they know how it works or not. They just start to do something and run at the same issues all the time. It happens again and again and again. First thing, microservices are cool, so we have to implement something with microservices. No. We implement something with microservices not because they are cool. Sorry, but that's stupid. We implement something with microservices because it's the approach to keep our application maintainable in the long term. And microservices don't make your application easier. Microservices just move complexity to different parts from monolith to the overall system architecture of the application. So it's not a magical silver bullet. I do microservices and everything will be great. Bullshit. You need to really understand how it works. For me, a great step to understand how it works was this book, Building Microservices from Sam Newman. It's a really great book explaining and opening really a lot of traps and showing like what could have been done wrong. So think of taking a serious look at these things. It's not a silver bullet. You have to be very careful implementing microservices. Or if and you may finish in the situation much worse than your old monolith thing.
It's a very good point. It's not an answer to everything. People think that, hey, I'm going to do microservices and they think it will solve all their problems, but they just created new ones.
Yes. You know, like that's an old joke. I had a problem. I decided to solve it with regular expressions, and now I have two problems. Good. So main thing of a microservice isolation is thinking of the business capabilities and products running small endpoints responsible for some domains or maybe workflows depending on your architecture. It's the idea to decentralize governance and decentralize data management. It really requires infrastructure automation because orchestrating a lot of services, containers mostly probably, is not going to be easy. So you will definitely need infrastructure automation and management automation. Otherwise, you will end up running it all manually, and that's not a simple job and very error-prone job if you do it manually. And last thing, we have to think about the design for failure. Before, I mean, it may sound like pretty bad. What do you mean design for failure? Should I design it so it will be crashing all the time? Nope. You should design it like it will be crashing all the time. Do you like it or not? So you have to think all the time what every network operation, every call for next service may be successful, yes, but it also can be failed. It can be extremely slow with very strong network lags, and so on and so forth. So you need to think of error handling and take error handling very seriously. So what's the main thing for us talking about the microservices from advantages and drawbacks? Cost reductions. So in very often development and deployment of microservices may save you some costs. Development of smaller applications goes easier than development of one huge application in some cases. Also, you can scale only what you need to. So you don't have to scale all your huge backend. You can scale only part of this backend, and that's great. Design is simpler. Design of a single service is simpler. Overall design of application may be more complex. Speed in development. Development for the single service definitely goes significantly faster. Well-designed microservice-oriented architecture application can be very resilient, and if you follow our words, so speaking about error handling and graceful degradation. Degradation or outage of a single microservice, if it's not essential, should not lead to any serious changes in the behavior on the main application for the user. It means what your application cannot at this point make any predictions, like you are selling some goods and people want to buy some goods, and you also want to show them things like, oh, there are very often those goods are bought together with what you are buying right now. Those suggestions like that, you've seen them many times, or Amazon or whatever you are using. If your suggestion service is degraded or fully offline, the only one thing should change. Suggestions should not appear at the screen, and it should look like it's fully okay, like it's designed to be like that. Because very often in the monolithic applications, well, in microservices done wrong as well, then the whole application will not be available. So stay very careful with resiliency and graceful degradation and error handling. Simple developments, yes, that's a big benefit. So every time you work at the smaller part responsible only for users, like when we speak, I don't know, for a user service or something like that, product service, it's not communicate directly with other parts of application. Security and monitoring, very well. So you have very granular control over every part of your application and better understanding what's going on in every part of the application, if you are implementing monitoring and logging properly, of course. Talking about drawbacks. Again, microservices does not reduce complexity. Microservices spread complexity over the multiple services. And from one point is good, if you know what's going on and if you know what you are doing, but you have to be careful. Complexity now is not the way how you use it to do it before, and it may take some time to understand how to handle that. Transactions management. Transactions management is very painful in distributed system. As like before you were doing a transaction, let's take an example. What's the transaction in this context? Like someone wants to buy something, I don't know, a laptop from your internet store. And therefore, you have to take some money from his or her account and also book the goods, like this laptop, for the customer, and it should be a part of a single operation. It should not happen like you take the money but never dispatch the laptop. People will be unhappy. And or like vice versa, you don't want to send laptop to a customer without taking money, obviously. So those are part of single transaction. Happens together, store it together always. But it works well with a monolith application. If they have multiple microservices responsible for operation, one service responsible for taking money, like accounting, I don't know, making bills, pulling money from account, and second service is responsible for products, and third service is responsible for shipping, which is very often use case. Therefore, they are not tightly coupled together. They are running at different instances in different amount of instances as they are scaled, and transactions management may be now significantly harder. Culture change. Yes, continuous integration, continuous delivery. Well, do you do monolith, Eric?
Well, no, I think monolith is so 1999, but with the going back to what you were talking about with the complexity too, a lot of people struggle with the fact that they've built so many tiny different services that keeping track of it becomes a headache too. So, that can be very problematic as well.
Yes. But in general, if you are doing, I don't care if you do monolith, service-oriented, microservices, whatever space architecture you can imagine, you must have continuous integration, at least you must have continuous integration tests. That's not a question, that's just a must. And preferably, that's for your sake, you should have continuous delivery. It really helps you to deliver resilient, well-tested, and customer-focused applications. And that's, but when you go with microservices, that's not like a must. That's some a real requirement. If you don't support continuous integration, if you don't support continuous delivery with microservices, you will fail, then that's not a question. And it requires some change for the teams, especially for old teams, let's say, who are used to do the things the same way all the time. Microservices require some microservices culture, including continuous integration, delivery, and fail-fast approach. But well, that deserves a very separate workshop, I would say. Good. And that's important for us to understand. So those are components very required for very important to think, thinking of microservices. Every very typical things what we are talking about. Every microservice should support things like health check APIs and distributed tracing. That's especially important. For example, if you have a monolithic application and you have something going on, so customer buys a laptop or something, when something goes wrong, you can see in the logs and see all the story. But if you don't have, and then if you have now distributed application, something went wrong, very often mistake can happen in communication between microservices. And therefore, if you don't have distributed tracing, all the parts of the operation which failed will look like standalone operations, and you will never be able to find the core mistake, like where it comes from. So you have to think very seriously of distributed tracing, like having transaction ID coming from the very beginning of the operation. Customer initiates and some change, like trying to buy something, you generate a transaction ID, and then every service processing this operation takes this transaction ID and uses it like writing to the logs and dispatch it to the next services. Those are required to communicate, to execute this order, and they're also handling this transaction ID. So when using some logging services, you may handle all the logs together and see what happened. If you don't know distributed tracing like that, if you don't have a transaction ID, debugging for distributed system like microservices or service-oriented architecture will be a true pain, like existential pain. And you have to think very a lot about the exception tracking, because that's also microservices, if they're done wrong, they are not transparent at all, and you will never be able to debug that. So think from the debugging and tracing and transparency of your operations from the very, very, very beginning. Otherwise, you will have really serious problems. Then, second part for us is testing. Every service provides an API to follow, and you know what? You shouldn't change API without announcing that and warning all of your clients like, okay, I'm changing API. If you do so, you will run again into very serious troubles, and no service will be able to communicate with one that updated. So you have to take testing inter-service communication very, very, very thoroughly and work heavily on that. So testing, 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 especially API-centric testing, is very important. API is a contract. You must follow your contract as you sign it that. So every service signs a contract, and you must take this contract, this API agreement, very seriously. And last point for us, especially important, is database per service. So usually for the monolith, you start with one database per monolith application. But the point is, as application becomes bigger, it works with different kinds of data. And different kinds of data require different kinds of database. For some database, for some applications, for some kinds of data, the best fit would be graph databases. And because they really care about the relations between entities. For some kind of data, relational databases would be the best fit. For some applications, you definitely need Cassandra. And it's really hard to work with multiple databases within the same monolithic application. It's possible, but then every next one makes architecture harder and harder, and it brings a lot of complications. Best thing of microservices, one of the best things of microservices to consider, you completely can use one database per service. For example, there is a group of developers, one team, working at the service which stores really a lot of time series data. Obviously, what Cassandra or Astra as Cassandra as a service would be the best fit. But for another team working on another kind of data, they need some graph databases to focus on the relations between entities. And they can use completely different databases, and it's perfectly fine. And they can use different languages. That's still perfectly fine as long as we follow API agreements, so service contracts. One database per service. It's great. What you need? Services must be loosely coupled, and each service is responsible for its data and isolated, and that's very important. One of the most important anti-patterns to consider is shared data. When different services working with the same database, with the same data, that's a very strong anti-pattern, and you should avoid it at all costs because it may bring to real problems. That's important to remember. Then, how that's related to Cassandra and why we speak microservices and Cassandra? Because Cassandra is a perfect fit for these kind of scenarios. We have data isolation using key space, and one service may go with one single key space, having this key space configured specifically for the needs of this service, and meanwhile, another service may still use the same instance of a Cassandra, but work with different key space. And data isolation per role-based access control in this case is a very good fit. To make it secure, to not allow any changes from unwished guests, let's say. Good. And well, same thing as we scale our services, we can easily scale our data to the services needs, having multiple rings, different replications factor, and still have the same approach, no single point of failure. Distributed architecture is not ACID, but base. What does that mean? I hope you know what's ACID already from our previous workshops or videos or whatever. Atomicity, consistency, isolation, and durability does not work anymore as it's the distributed system. In distributed system, you can reach ACID requirements, you can match ACID requirements only in one case, if you are fine blocking your system for many milliseconds or even seconds, or in some cases, even minutes. ACID doesn't work well in the distributed environments, especially with microservices, as like in the example I gave you before. Order management service and customer management service are two different services running on two different instances, and they are communicating via API. We have to think of that, and we cannot apply ACID here. And we think instead of that, of basic availability, soft state, eventual consistency. That's a different approach. What does that mean? Availability has higher priority than consistency, considering what consistency will be reached after an operation or two. Event sourcing, we're saving messages, or better to say events, mutations, changes, and not the final state. So we are able to replay these messages or events if required. And idempotence, it means messages should be replayable. What does that mean? We explained it above, but let me repeat. I want you to really understand that. Idempotent message, it's like set username equals Alex. You can repeat this event as many times as you want. And username still will be Alex in the end. But if you do an operation, increase counter +1, and then you repeat this operation many times, the counter will be increased many times. So event duplication may lead to big problems if they are non-idempotent. So we always suggest to prefer idempotent mutations. Apache Cassandra loves microservices, and microservices loves Apache Cassandra. Real-time requests, so database is very, very quick. And scalability and core, you can scale your data with your services. Very easy and can be fully automated if required. Cassandra is a very good fit for distributed architecture, supporting exactly the base approach. Implementation is important for us. CQRS, we will say a word about that in a minute. And event sourcing. And we can call, yeah.
This was a bit contentious yesterday, Alex, in the workshop, because in the yesterday's session, because a lot of attendees were asking, if Cassandra doesn't do ACID, then does that mean that banking and financial institutions don't use Cassandra? And the truth is that's the wrong idea, because there are a lot of institutions out there that use Cassandra. ING is one of them that use it for ledger-based recording of data.
Yes.
So it doesn't have to be ACID.
There is a very good example. When we start to speak about the Cassandra and distributed data storage and how it works, many people like, okay, so eventual consistency, replication. So you can't use it for real data because it's like eventually consistent. And when I want to ask what's the biggest distributed eventually consistent system you use very often, or you use all the time, it's very simple. That's exactly the financial or money system with ATMs, cash machines, and stations at food stores or whatever, where you pay your money with your card and you can get some cash from the cash machine. That's distributed, eventually consistent system, because there are no guarantees you will have network connection between multiple different points, and you still have your money at your card and it works perfectly fine. That's exactly the same distributed, eventually consistent application. Good. So, and decoupling by design, we speak of one key space per domain. Domain in the meaning of like subject, topic, the service working on, and one query, one table, which works very well with this approach. And we want to start with Astra application, which is a part of our exercise for this week. So, give me a moment. We have here a Cassandra Workshop series, week 4. I will make it a little bit bigger, so hopefully you can see it with me. And let's do the first part of the exercise very, very quickly. And prerequisites to do this exercise, you need to have an Astra instance, and you need to create a data model from week 3. But right now, I suggest you not to do it right now, but watch me. And when it will be operational, you do it exactly the same way in the exactly after the workshop. So important parts for us: Astra instance and data model. If you didn't do a week free before, it's required to do week free before because there are some dependencies. And we have three backends: Java, Python, and C#. I will do it following Java backend. For others, it should be exactly the same. So first we need to know is to run a backend. Two ways: Git pod or your local environment. You can do it at both sides, whatever you prefer. I prefer to open a Git pod. Oops. Yes. And very important notice, if you are working at Gitpod, by default, autosave is not enabled. And a lot of people run into troubles because of that. So you have or to manually save your files, Control S or Command S or whatever at your system. First thing. And second thing, you can simply enable autosave. And that's really recommended to do. Yes, good. So it goes well for me. And I have to go, I will make it again bigger. I have to go to week 4 application development API, and I will go to Java. If you will do not Java, follow the different instructions. All the instructions are specified here at the Cassandra Workshop series, week 4. Good. So I have to switch my terminal to be at the getting started with Astra Java. And now I have to execute the Maven Spring Boot run as we prepared everything for you. At first, it may take some time because, well, it looks like Maven is going to download the whole internet here. So I will go on with the next steps and we will get back to it just to save some time. If you are doing not Java but other services like Python, instructions may be a little bit different. You may need to install Flask course, and Cassandra driver, for example. For Java, it will be installed by Maven automatically. Good. Okay, it looks like service is running and we can open that. Good. So by default, I'm being redirected to Swagger. If you don't know Swagger, it's a great tool to document your API, document your services, how do they run, what arguments they need in their API calls, and so on. And in this case, following the week 3, at week 4, we are going to work with spacecraft controller, so I can open it and see all the available API calls for me, and some models I can use. And let me proceed to the next step. Next step for me will be to, yep.
So
yes.
Just to mention quickly, so Python doesn't have the Swagger UI. So just if people are trying out the Python example, and C#, you have to do it on your own environment because it doesn't work on Gitpod. There's a problem with the SSL.
Yes. So yeah.
But
so don't forget, if you're doing Python, you will have no Swagger UI, but that's perfectly fine. Application is still working. Good. Then next thing I have to do, I have to start user interface. So backend is running. Backend can execute our queries already. but we don't have a front end to run it, and we have front end for you. So I need to start the UI. For this, to do that, again, I am doing that at Gitpod, so I don't want to run everything locally. Node.js, Java, Python, you know, like it's very messy nowadays, so I will run a new terminal. I will switch to week 4, and I will switch to getting started with Astra UI. What I have to do now is I have to do npm install to install all the dependencies. It's again takes some time because despite Maven is pretty greedy, npm may be even more greedy. So again, downloading half of the internet to get all the things. And now we have to do important thing. Notice, following the services isolation, we have 2 different instances running. One instance is backend. It's launched in my terminal first, and it's still running. Getting started with Astra, blah, 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 JVM running. And the second terminal is responsible for front end. Now it's installing dependencies, but I will therefore start it in some moments, and we will have to make them to communicate. As it's explained in the documentation in the README file, to run them, you have to configure base address in the env file, .env file, and this .env file will be used for from frontend to know how to find the backend. And
so just to clarify that, so the base address is your Git pod URL. Which when you launch the Swagger UI, the end of your URL would say /swagger UI.html or something to that effect. You just have to strip out that Swagger UI part of the URL and replace it with /API, and that's what you put in your .env file. Because a lot of attendees were confused about that yesterday.
And you know what, Eric? Do you know what's the most important in this .env file? The most important.
What do you say?
The most important in this .env file is to put it in the proper directory, because a lot of people I've seen created it in the wrong directory and then nothing works for them. So you have to create .env file in the folder week 4 AppDev API getting started with Astra UI. Otherwise, it will not work. And as a base address, exactly as Eric say, we are going like this Swagger UI address. So for me, it looks 8080, if BE, blah, 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 blah. For you, it will look differently because you will have your own instance. And I put it right here. And I add API in the end. So it looks like base address equals HTTPS 8080, blah, 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 blah. Very good.
Localhost won't work here, so don't use localhost.
Good. So my .env file looks exactly as it should. Hopefully, let me check once again the documentation. Base address, yeah, looks very good. Now, I can try to run the application. npm run start. If you are not experienced with Node.js and npm, don't worry, that's not a big deal. We prepared everything for you. You don't have to be a front-end developer to run that. Okay, so I see what service is available on port 3000, and it's compiled successfully, so we are fine and we can open browser. Guess what? We have running, we have front-end running, and hopefully it will be open for me. Should be open at least in a couple of minutes. But what we are missing right now is the configuration. So, oh, perfect, it's ready. So we need to connect to our Astra database. Every one of you has his or her own Astra database, and we need to connect that. If you follow it, the exercises with us before thoroughly, you know username, password, and key space. So for this one, I will use kv user, password kv password. For you, I hope it's the same. My key space will be killer video. And now, choose your secure connect bundle. I hope you know that already. You should, it's week 4. But if you didn't, we have here DataStax Astra. And that's my account at DataStax Astra. And here I have a button in Astra databases, my database. I have button download secure connect bundle. And I have to download that. Oops. Okay, I have to renew the page, sorry. Anyway, I have downloaded this file already, so I don't have to download it second time anyway. And then here, I drag and drop your secure connect bundle here or click to choose. So I click to choose, and I choose my secure connect file, and I can test connection. And connection is wrong. What the hell? Let me check the password. KVPS. Oh. Just one more time. Okay, something doesn't want to connect at my side. Then let me use plan B. Okay, so I have plan B. While it's being started, it will take some minutes. I suggest us to move on to the next slides. And we will get back to the exercise in some seconds. So, talking about this microservices architecture, this workshop is the next step of the week 3. What we did at week 3, if you have forgot or didn't yet, I will tell you. We created a data model for our Astra journey. So there are spacecraft journey catalog registering different spacecraft flights. And therefore, we register spacecraft speed, temperature, location, pressure, things like that in the database. And the model is created in Astra already during the step week 3. If you didn't do week 3, you should do it right now. Then, today we're working at the communication of front end and back end therefore. And that's again the step to take a look how it goes for me. Maybe my second part, maybe my plan B is started already. Okay, not yet. Yes, it started already, very well. So I'm going to open it in a browser. And again, KV user, oh, thank you. KV password, key space killer video, and drag and drop my connection bundle. Last time it didn't work it at the first attempt, but work it at the second attempt. Yes, test successful and we are connected. Perfect. So that's the front end working with our backend. We created data model last week. We created the application for you to work with this week. And now we have this front end. So as soon as I'm fine with the user interface, it started very simple. Down you see some location and pressure and speed and temperature values. And upstairs I have a launch new journey button. I will try to make it a little bit bigger so you will see it all. And what happens when we launch a journey? We launch a new journey is created for the spacecraft you specify. And a lot of sensors readings are generated for speed, pressure, and the location, imitating the real space flight. And all those data is stored very quickly into your Astra instance. So we will see it in Astra in a moment. So I want to specify the spacecraft name. I will call this spacecraft, for example, Gagarin, in the name of first man in the space, Yuri Gagarin. It will be Gagarin 1, for example. And journey summary will be, I don't know, trip to Astra. And launch. So we're preparing everything for launch, and now we start to do a lot of work making your database busy, sending a lot of sensors, changing metrics all the time to the database, so we will have everything for this flight executed. I like, Eric, I really like how this front end looks like.
It's very trippy.
Yeah. Looks like for real. Reminds me of Star Wars, but maybe we need to set hyperspace drive to make the jump quicker. But well, it would be fantastic. Okay, and we are almost reached our goal. Yes, journey summary. Gagarin 1 just did journey ID, well, blah, 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 long ID. And we wrote a lot of different details about this flight to the database. And what we can do right now, we can go to DataStax Astra. So I will go to mine. You can open DataStax Studio. And to work with the data of this flight, you need to have notebook installed from week 3. And I already have this week 3 notebook installed, therefore I don't need to do anything here, and just launch this notebook. If you didn't have it yet, if you don't have it yet, you have to do week 3 and upload this notebook and prepare everything and create the data model. Notice what data model was created during the last week. So, and here, as everything is created, we can go and read different details from our flight. So I want to just select all. As you, oh, okay. So, okay, perfect. My spacecraft is here. Journey ID is here. It's not active anymore because it's done. It's finished. And that's my summary, start and end. And in the other tables, I may find, so yes, that's spacecraft location over time. I can find other things, what's interesting for me. So, we have to move on, but that's the idea of this exercise. And don't forget, you may have it done with Python or C# or Java. Python will have no Swagger enabled for you, but well, it's not the most important part. The most important part, you have front end communicating with your backend, communicating with your Astra. Good. Some next things for us to cover. Endpoints and access patterns. So There are, in general, three kinds of patterns, ways how we access a service or database. In this case, doesn't matter. Case when you are going to upload huge volumes of data, but usually it doesn't happen so often. So if you see at the left side, you see file exchanges. That's a situation, then you want to upload some gigabytes of data, but mostly probably you aren't going to do it every hour. So we speak about small amounts of times you do it. And for this case, when we want to load the data like that, we think of the following tools. Typical tools for Apache Cassandra when you have to load data. We speak about SQLSH with copy from. It may be sometimes the best solution if you have your data prepared for SQL. But also we think of the DSBulk, which is a very good tool to load data, having it in CSV, for example, load or unload. It works very quickly. It's now open, so you can use it for Cassandra. Before it was only for DataStax Enterprise. Now it's for Cassandra as well. It's still proprietary, it's not open sourced, but it's available for free and you can use it for your Cassandra databases as well. And typical way is SS table loader, allowing you to load and unload SS tables. And of course, very often use it Apache Spark for that. Second kind of behavior, second kind of a use case you may consider are messages or events. Speaking about change data capture, CDC stands for change data capture. Very often case is Apache Kafka. Kafka works perfectly with Cassandra, so there are some integration tools. And if you want to dispatch messages of a big volume and happening regularly, obviously, Kafka is a very good fit for Cassandra, and we work together very well. And last use case we have to cover is normal request reply approach. I bet you've used it many times before. And in this case, we speak about API things. And I have a warning or reminder from a friend of mine. It looks like we secretly open sourced DSBulk, but it's not yet announced. Okay, so you see, every next day DataStax got closer and closer to be as open sourced as is technically possible. Good. So with DSBulk, it's very simple. If you want to download a lot of data, you have it in CSV or JSON, it may be the best way to download or upload a lot of data for Apache Cassandra, for or from. Message ingestion and Kafka. With Kafka connectors and Kafka syncs, it's really easy to put. So if you don't know what's the Kafka and event streaming in general, sorry when I have to say a word about that. Consider that as a multiplier. Like imagine you want to connect to electric your laptop, and you want to charge your mobile phone, and you want to connect your, I don't know, coffee machine to make coffee for yourself, and you only have one power socket in the wall. Obviously, you can connect only one thing at a time. So if you want to connect many things, you need a multiplier to have sockets for everyone available. That's basically the idea of Kafka. I bet some guys from Kafka team would be not really excited of this comparison. I hope they will forgive me, but in very simple, that's the idea. You send an event, you send a notification from your applications or IoT devices or whatever to Kafka connector or source connector. This event goes to Kafka cluster, and then it's being dispatched to all the interested subscribers using syncs, and then you may store the same data to process at the same time in Cassandra and something like Apache Spark for analytic purposes or DataStax Enterprise and all the other things like that. And that's a really great architectural tool. In some cases, you may want to have your events on multiple receivers. When when we speak about request reply, we have to consider three possible approaches: synchronous queries, asynchronous queries, and other steps in these fields. There are three mostly possible approaches. Let's take a look at the synchronous queries. Everyone have used them. That's a very typical way. Then client sends some parameters to API. Your APIs or your application uses prepared statements in parameters having with driver, bind these parameters, and send a bound statement to Cassandra. And then Cassandra returns the result, driver sends the result set, API sends the results, client receives the results. Normal workflow, but there is one very strong downside. Client is being blocked all that time. So yes, that's the downside of synchronous queries to consider. When we start to think of asynchronous queries, which work is a little bit different way. Client send parameters, API prepared statements and parameters, driver bind parameters, send bound statement, and in this case we have a completion stage. There are no results yet. The order is not executed, but the client is already unlocked, and user interface may show something. So it's a non-blocked way, asynchronous way. Then asynchronous result set being returned to driver, to API, and to your client as a result. And therefore, you receive your result at the same time, but client user interface behaves much quicker and it doesn't look like it's blocked. And the previous approach, this one has some downside to consider. Although for a user it's better, but it's not so better for developer. It's a thing called well known as callback hell. And we have to remember that very seriously. Callback hell is when you need to react on those async results set, and you have to do this, that, and that. At some points, it's very hard to maintain. Reactive queries work differently, so it's the advanced approach of asynchronous things. In the beginning, it looks exactly the same. Parameters, prepared statement, byte parameters, and then we have bound statement and reactive result set already delivered with Flux, and we subscribe to the event on completion. Then on next reactive row. So query execution when will be done, and as we subscribe it for this event, we will receive this event as soon as it's done. Approach is the same. So the idea is to be non-blocking for your client. You receive your client focus and the user interface the same moment. And it allows you to have all the benefits of asynchronous queries while not having callback hell. So that's a very advanced thing. And on complete, you have everything delivered. And I was talking so much, and you were waiting all the time for the quiz, I believe. So we want to have quiz, and we want to answer questions, and some of you will win some prizes today. So let me switch.
So while you're doing that, Alex, I'm just going to remind everyone. So we've got like just under 300 people watching the stream right now. And I think it's time for everyone to go and hit the like button while Alex is doing that. And also please hit subscribe so you get notified when we have new workshops happening as well.
Okay, it looks like I should reload MENTI as usual. Oh no, it looks better now. API.
Thank you. We've had 6 people hit like so far.
Yes, so I see a lot of people ready. I give you some more seconds to join, and we start because first question is ready. Don't forget to join the quiz. You have to go to menti.com and use code 436982.
On your mobile. Don't follow the one on the screen because it's the stream is delayed.
Yes. Okay. 67. Okay, 5 more seconds. Again, as Eric just said, but it really worth repeating, answering Menti, please follow your phone, not your screen, because YouTube brings some delay to the screen. So now I don't say too often, don't listen to me, watch your mobile phone screen. It really may be faster for you delivering the answers. Okay, so let's start. Question 1, and we are starting. Answer fast to get more points, but don't forget you have to answer correctly. Why monolith architecture are often considered bad practice? And now you have some seconds to answer. Okay, we have around, we have many dozens of people participating. That's nice to see. 3, 2, 1. Time is up. So let me see the answer. Okay. The correct answer is all of above, and I see a lot of people were in a hurry and answered the first matching answer. It was a trap. All answers are correct in this, so you have to choose all of above. They tend to grow out and become unmaintainable. Yes. They are often harder to scale. Yes. Tightly coupled code tends to impede development. Yes, so all of the above is the correct answer. And let's take a look at the leaderboard. Okay. Very close results. Clippy was the fastest. And Puggy and Earthman, okay, but very strong competition. Let's move on to the next question. Mike?
So it looks like everyone got the default username. That's okay.
Yes,
we'll
microservices are the method to ensure tight coupling, the way to isolate domains and workloads and reduce coupling, require enterprise service bus to communicate, good only on Raspberry Pis. Well, those are microservices, so you need to have a proper hardware. Okay, so this one was good. Nearly everyone answered correctly. The way to isolate domains and workloads to reduce coupling. Correctly. Microservices does not require enterprise service bus to communicate, and that's not a method to ensure tight coupling. Tight coupling is bad. And leaderboard may change, but all the leaders answered correctly at least. So let's see how it changes. First name, V. Roshan, and I bet that's the same clip, the same name, I think. So at least the same icon. Hemanth at the second place and Utpal at the third place. Call me Tesla, very close, fourth place. Keep fighting. Good, let's move on.
Rajiv, I think you were here yesterday.
Asynchronous queries respond faster than synchronous. Don't support bound statement. Do not block clients for better usage of resources. Receive response before sending request. Oh, I would love to have that.
I like that time machine.
So, correct answer is asynchronous queries do not block client for better usage of resources and better user interface. Answer, respond faster than synchronous is not correct because database will need exactly the same time to execute your query. So answer will be delivered at the same time, but client will be not blocked. So the first answer is not correct. And answer don't support bound statement is wrong because they do support. And what's the changes in our leaderboard? Who is the winner now? Okay, it goes close. No one did a mistake. And we have Viroshan at the first place, Utpal now at the second, and Call Me Tesla did it. You see, I told you, keep fighting. Good. Rajiv Soni, fourth place. Hemanth falls to the fifth, but still in the top 5 list of answers. And Karthik was the fastest this time. So, REST, representational stateful transfer, is a remote implementation of a procedure call. API based on the HTTP methods. API offers great discoverability. REST is required after a long workshop. Well, obviously, the fourth answer is the most correct. There are no questions. Yes, but you know everything. REST API is indeed based at the HTTP methods, and REST is definitely not a remote implementation of procedure call. And no, I'm sorry, REST API by default at least does not offer great discoverability. Exactly opposite. And what's the changes at the leaderboard? So familiar names. And what's Utpal was fastest, but still at the second place. And Call Me Tesla holds the third place, but the gap between winners is very small, like a dozen of points. So very, very, very close competition.
There's still a chance.
Yeah. Do ACID requirements fit microservice architecture? Yes, if support ACID configuration is explicitly enabled. No, distributed isolated architecture is better fit for base. Yes, microservices perfectly support ACID. No, microservices are alkaline. Time is up. And the correct answer is no, distributed isolated architecture is better fit for base. Exactly correct. And what do we have right now? Any change? Havana was fastest, but it didn't bring him only to the fourth place. It's so first place, V Roshan, first place, 4,906 points. It's a great result. Then the second result, very close, 4,888. Call Me Tesla, second place. Congratulations. And Utpal holding the third place just 1 point later after Call Me Tesla. 1 point difference. That was really close.
Well done. Congratulations. And so send your details to so the top 3, Viroshan, Call Me Tesla, and Utpal. Send your message to send a message to jack.fryer@datastacks.com with all your details, your full name and your full address, and we'll be sending you your prizes.
Exactly. And don't forget, well, that still are not the best times. So in some cases, dispatching prizes and transporting them may take extra time. So don't expect to get them next week. I'm sorry. I would love you to have them today, but there is no way to achieve that.
Right.
Good. So there are some more things to consider. Call that API. And there are 3 very important tools for us to think of. Don't forget, before doing any development, first solve the problem, then write the code. People do opposite all the time. They first writing code, then start to think. No, think first. And design of your system is very important. So think not only about the services and code by itself, because it's easier with microservices, but think of the overall design of your application and architecture, and think especially about APIs. APIs are everything in the distributed architectures like microservices architectures. So, where is my rest? Okay. GraphQL is a relatively new thing. It's not used so much everywhere, but a lot of people start to speak about it now, and I see it more and more often at different conferences, talks regarding GraphQL. It definitely deserves your attention because it brings some very positive possible changes to your API and very nice with some nice ways to communicate for clients with your application, like possibility to specify different required things and discoverability of your APIs. So like API says what you can do with me and which functions you may call, how you may reach the data, and so on. So GraphQL is a new thing. Some people may be afraid to use that because of that. Well, it's kind of not battle hardened, but it's a question of time and it deserves your attention. So spend your time, watch out for the GraphQL. It may be a very interesting way to give your better visibility over your data. When we think on gRPC, I believe you know what the RPC is, so remote procedure call. It's like a procedure call, but remote. So gRPC is a modern, high-performance RPC framework. It works very quickly. You can run it in any environment, and it's a really good way and fast way to get some data using the familiar approach with remote procedure calling. It has a very simple service definition. So you describe your API with simple protocol buffers, and you have the kind of service agreements, what you can use in any tool set and language. Really easy to start and start work and scale. There are multiple tools available, and it can work very, very quick. Works for different languages and platforms, as said, so you can generate a simple client and stubs for your service using automated tools, which simplifies development process for developer. And it's very good for bidirectional streaming and integrated authorization. So there are multiple tools available to support these kind of things. Speaking of what's good for you and what's bad, don't take this slide seriously. That's mostly just a joke. Hello, Cedric, by the way. I know you're watching that. So there are a lot of different research is done, like which one is better, GraphQL versus REST versus gRPC. And like a normal decision tree looks like that, and we are not going to use that. We have some much better cards for you, so you can watch those cards and remember them, maybe screenshot them, download them, post it as a posters on your wall, because you may need them for your future great applications. When we speak of the REST, first we have to remember REST is good for decoupling client from server, so there are no strict schema, and in some cases it may be for good. It's very flexible, so you can have it synced, asynced, reactive, very different ways. Very fine and very easy to support versioning and use different API endpoints in different API versions at the same time. And as it exists for dozens of years, of course, you have all the tooling you may need for API management, for serverless things, so that's a well-known and very well-known approach. From disadvantages, we may think payload of the REST requests are usually pretty heavy, so they're JSON or XML, and not always easy to read for a human, let's say. They offer no discoverability, so if you want your API to be self-discoverable, you can do it still, but you have to provide additional steps for that, and you need to have to do additional job. In comparison with other approaches, it may be not the best thing. And it's definitely not the best fit for command-like functions, API kind of things. Let me explain that because it may be not clear. REST is based, as you've answered it correctly, on HTTP methods. And there are not so many of them. Usually you use like get, post, put, delete. That's it. And those are 4 verbs, 4 functions you may use with REST. And if you implement something like create, read, update, delete, which fits into this limit, then it's great. Then REST can be a very good choice. But if you implement something harder than that, so if you implement like business level functions, hire an employee, make an order, and so on, so there are many options, many verbs which don't fit in this create, read, update, delete thing. And therefore, if you want to have extensive API with very many different functions and human understandable maybe, then REST may be not the best choice. So as a result, REST is a superstar for create, read, update, delete use cases. Very simple, very good. Very relevant for normal OLTP mutations and statuses. So for databases like Cassandra, nearly everything what you are doing with Cassandra usually feed into the create, read, update, delete use case, of course. And it's very simple to use for public and web APIs. So there is nothing to add. Very common use case to have REST API available over web all the time. When we're speaking of gRPC, positive sides, high performance, it uses HTTP version 2 and binary serialization. It's very, very fast and very small. It offers multiple stops and you can work with sync, async, and streaming and things like that. Implemented in many languages, so there should be no big problems for you, like whatever language you use, except of some maybe the most exotic ones. It's strongly coupled in the meaning of data. So you declare your schema with protofiles, yes, and hey, you must feed those protofiles requirements. You cannot just boom and start to dispatch a new kind of a data, new set of data, like you could do in REST. It still offers no discoverability. And well, I know not all of the people are happy with protobuf serialization format. So in the end, it's good for distributed network of services in command-like remote procedure calling style. It has very high throughput and streaming use cases, and that's definitely also a tool for you to consider thinking on APIs. GraphQL. Very good from the discoverability and documentation point of view, kind of self-documenting and self-discoverable. In many use cases, it may be important. It supports custom payloads and much standards, like whatever you can use, it fits very well. From the downsides, we can think as a single endpoint, and it may be harder from the versioning point of view. Relatively complex implementation. So by itself, well, it's very useful, but ecosystem and tooling may be a little bit too young altogether. Nice for complicated queries when you want to have some very sophisticated questions for databases. Very good for as backend for frontend. So your front-end parts of your application, like single-page applications, can communicate with GraphQL very simple and nice way. Supports service aggregation and compositions with kind like a joins and can communicate with multiple services, which is pretty convenient. And also pretty good talking on the data volume. So when you want to have your all of your data minified and bandwidth matter, then it's could be a good choice. Oh, designing REST API with application workflow. Well, we did that already. Spacecraft catalog queries, we've seen that today. And I want to get back. Okay, my workplace is stopped. I wanted to show you a thing with Swagger. Given this application we've seen today provides REST API, you can really easily use it with Swagger and imitate different queries having Swagger. It's available and specified in documentation if you run Java version. It sadly not supported in the Python version. Good. So, typical way to design your API with REST. You already know we go with URIs to specify what we can reach. So, very good practice to use prefix, sometimes with major version. So if you are using REST APIs of different applications already, you could have seen API slash version 2 slash. It means what currently we are working with the endpoint supporting second version of the API. When we usually specify entity, in this case, it will be spacecraft, as we are working with spacecrafts in this application. And we can list all the details and journeys for this application, specifying the spacecraft ID. In this case, we use name as an ID. And journey ID will allow us to retrieve all the details for the given journey. And then we can see how it looks in the Swagger-like view. Attribute and value table. Attribute is method. It will be HTTP verb get. URL we use API v1 spacecraft name, request, and possible responses. As REST is based on HTTP very closely, it looks really like a normal HTTP query. 200 we dispatch list of journeys, 200 for no content, so no journeys have been registered, 404 spacecraft not found, or 400 bad parameters, so wrong spacecraft name, like very wrong, not just not found, and 500, okay, something that front our service, it can deliver the response. Typical view of the Swagger UI, the spacecraft controller, given we explain it to Swagger what's our API, you can see and use those methods, get or post, to retrieve data or store data about a new journey. And with instruments controller, we read data, read and store data for location, pressure, speed, temperature, and other tools. Logical architecture is very simple here. So Node.js works. We're using REST API with a backend application, and backend application uses Cassandra driver to communicate with DataStax Astra, Cassandra as a service. And DataStax team takes care of running and maintaining Cassandra, so you should not take care about that and spend too much time on that, which is good. So we started UI and demo already. And last thing, well, almost last thing we want to talk about today is Quarkus. Eric? Hi, Eric.
Yep, here we go. So here's a really good one. It's for me, it's a fairly new technology. So it supports a different kind of VM. So particularly with Graal VM, and the idea with Quarkus is that you can deploy stuff with a much smaller heap. And I think one of its biggest advantages is that everything is pre-done. Everything is pre-packaged for you in such a way that when you load it up, it loads up really, really fast. And in a lot of environments, this is important because then you're not paying for the execution time just to start up your instances. So that's one of the really good things about Quarkus. Has anyone that's watching this stream used Quarkus
Great question.
before?
Indeed, if you have used Quarkus or at least considering Quarkus to start using it, please write in the chat or Discord, because we are very curious how much of adoption in the community for this tool.
So if we go to the next slide.
Done.
So yeah, so there's a new announcement that happened maybe it was 2 or 3 weeks ago, where there's now a Cassandra support in Quarkus, where you support the driver sessions and the object mapper as well. You can now deploy Cassandra use Cassandra with Quarkus, and we also support it now for Astra. Yeah, so I'm just reading some of the comments here. Yeah, so it's for me it's fairly new. It's been around for quite some time, but for me it's something that new that I'm looking at as well. And there's quite a lot of buzz around Quarkus. It was something that we had to quickly get on board as well, and it's very useful and very helpful if you really want to go with a cloud native environment, where particularly if you're heavily into Kubernetes deployments as well.
Good. So we are almost done for today, and we are very on time. We have a little surprise for you, and that's a really exciting surprise. I really like the approach, and well, I'm happy to announce that because we want to run an Astra hackathon or Astraton or Astracaton. How do you name that? So great news. We are talking and talking, but talk is cheap. Show me the code. So now you show us the code, and with next 4 weeks done, you have the knowledge to start building your application with Cassandra and clouds and microservices and things like that. So we're launching an Astracathon. 4 weeks, so end of submission will be 26th of August, end of August. You have to build a real app with Astra, free tier. Pick the language you are confident with. So I don't know, whatever your choice, as long as you have a driver for Cassandra available, it will work for us. All source code will be shared with everyone on GitHub, so it's open source. That's not a proprietary thing. And there are real money to win. And the judges will be Patrick McFadden, Vice President of DataStax, Jeff Carpenter, author of Cassandra Definitive Guide book, and the whole advocate team. So every of the advocates you've seen so far. And okay, what's the prizes then? Prizes, well, there are some nice swag, but talking about the money prizes, there are 3 first places. Money talk, yeah, absolutely. Gift card of $100, second place gift card of $200, and first place is gift card of $300. And that I hope you are as interested as we, because we are very interested. How do I get evaluated? We assess 3 main things. Data model. I did the workshop with you second week with data model. I hope you remember me. I take it very, very seriously. So your data model choices and decisions really matter. Source code, quality, and best practices. Yes, of course. I mean, high quality code is, well, much better and easier to maintain. And we want you to know those best practices, and we want you to write a high quality code. Easy of use is also, well, important. If we cannot run your application within 15 minutes, then mostly probably something is wrong, as we are pretty experienced developers. So you need to have a good documentation, maybe a Docker image. If you are using Docker, Docker is not a requirement, so you don't have to spend your time on Docker. But anyway, there should be a clear documentation how to launch your application. You may have your ideas. Great and amazing, and go for it. If you have no idea, there is a data models collection. You may pick one which you like the most and implement it with Cassandra and Astra. For submissions, please use astracathon@datastax.com, and you must be registered for the series, obviously. So that's an Astracathon for the attendees of this Cassandra Cloud Native Workshop series. 2 more words. We are upgrading our certification process, and we are upgrading an academy. Eric, maybe you can say a couple of words about that?
Yeah, so a few hours ago, so maybe 10 hours ago, we upgraded Academy. So for those of you who are wondering, you cannot do any certifications at the moment. You can't do exams. And some people are asking why they can't see their previous certificates for the ones who are already certified. And this is the reason that we haven't been issuing vouchers. It's because you cannot book at the moment. So if you go to the workshop materials page for week 4, there's a frequently asked question there where it explains how you can register your interest if you want to get certified. But so the Academy looks different right now. But we'll get it up and running as soon as we can just for the certification. It will happen in the first week of August.
So what we want to say really right now, do not worry. Academy doesn't work for you. Do not worry. It's fine. It doesn't work for everyone. Sorry, just kidding. So it's being upgraded, and it may take some time, and it may bring some issues, but in the end, everything will be fine. And you still have most of materials available. If you have any issues, contact us. And certification provider, you know what? Do not worry. You will pass you will get your voucher. You will pass your exam. Everything will be great. Do not worry.
So Sasha Torres was asking, they've got a certification booked for the 30th of July. You'll need to reschedule it. You'll need to go to that FAQ page to register, or contact Jack Fryer. It will get rescheduled.
Yep. So in the end, do not worry. Everything will be fine. Now, speaking about do not worry, they have a very exciting news. Finally, after very many years of development, the most stable release in history, Cassandra version 4, now finally reached beta 1 state. And that's really great, and that's just incredible news because there are plenty of great features, especially speaking about the operations, self-recovery, maintainability, traceability, and I mean, I'm really excited of this release, and there's we have a special Accelerate release, our online series about Cassandra. You may watch it today. It's a really interesting one. Contributors of Cassandra version 4 speak how it was, how it's delivered, why we say it's the most stable release in history, how it was tested, and so on. How it was tested, by the way, we will have a workshop regarding that some weeks later. Good. Homework. First, do your exercises. I don't want to do your exercises while trying to listen to me and do your exercise at the same time. That's a no-go. But do your exercises now. Right now, use Gitpod or clone the materials at your own laptop and do the job. Take it for real. That's serious. Then, watch talk introducing Kafka and Cassandra. I hope we have links delivered.
Yeah, so on the materials page are the links, the short course for the Kafka and Cassandra at the Academy. The link that I've got in the materials page is for the old site. So I'll update it a few minutes after the workshop with the link that you can get to in the new Academy site.
And we have course on Kafka and Cassandra at the Academy site, yes. Watch Accelerate, Data Stacks Accelerate. It's fun, especially the last one. That's just hard to explain. You just have to take a look if you have time. And if you are looking for some nice tricks going to develop your application working with Astra, then upcoming webinar 10 tricks with Astra may also be very handy, but that's an optional. Practice, finish workshop exercises. If you need following guidance on GitHub, if you have questions, Discord or community.datastacks.com. If you are interested in Quarkus, you can watch our Cassandra Quarkus example at github.com/datastacks Cassandra Quarkus. And don't forget validation form of the week, the way you confirm your presence and validate your answers and being officially confirmed for this workshop attendance. Thank you so much for being with us.
Thanks very much. So don't forget to hit like and subscribe down below, please.
Yeah,
hit
you see,
like
Eric?
now. There's almost 300 people in this workshop right now. I need you to hit the
So
like
where is
button.
the Eric? And below Eric, you have like and subscribe buttons, and you absolutely must press them. If you liked this workshop, we deliver much more of a great content. So that was Erick RAMIREZ from Australia, Aleksandr VOLOCHNEV, and we are very happy what you were here with us, and see you next week, and good luck with your exercises, and especially good luck with the astrocaton. Have fun. See you next week.
Thanks again for joining us.